problem, given that in a children park, an inclined plane is constructed with an angle of incline 45 degrees in the middle part as shown in the figure. Here figure was given, students. Find the acceleration of the boy sliding on it if the friction coefficient between the cloth of the boy and the incline is 0.6 and g given 10 meter per second square. So first you draw the free body diagram, students. Here this is a free body diagram of the boy on inclined plane. Okay, so here this is the boy, students. FBD of boy I have written on inclined plane. So gravity acts vertically downward and normal reaction is acting normal to the surface. If you resolve gravity along the plane and perpendicular to the plane, then students, along the plane you will get mg sin theta and perpendicular to the plane you will get mg cos theta. And here this theta is by the knowledge of geometry, you will write this. Okay, and theta is the angle of inclination and it is given as 45 degrees, and coefficient of friction is also given 0.6. Therefore, on considering friction in this FBD, students, it will act opposite to the direction of motion of the body. So let us consider boy is accelerating downward with A. So therefore, if you write down the net force equation, then you will get the net force equation as mg sin theta minus fk is equal to m into A, because here boy is accelerating in the direction of mg sin theta. That's why mg sin theta is greater than fk. Therefore, you will write like this. And in this situation, fk is equal to, all the time we will write mu k into n. And here, students, from the figure you can write n is equal to mg cos theta. Then fk will become mu k mg cos theta. So therefore, on substituting fk value in the first equation and simplifying, we will get acceleration as g into sin theta minus mu k cos theta. And students, you can use this as a formula for acceleration of a body down the inclined plane, rough inclined plane. Okay. Now on substituting the given values, we are getting acceleration is equal to 2 root 2 meter per second square. That's it. In this problem, it was given that a body starts slipping down an incline and moves half meter in half second. How long will it take to move the next half meter? So students, here nature of the inclined plane is not mentioned. Only it was given that the body is started slipping down an inclined plane. Means we can take initial velocity as 0. But we are not sure whether it is rough inclined plane or smooth inclined plane. But students, if it is rough inclined plane, you're going to get acceleration down the plane like this. Otherwise, you are going to get acceleration as A is equal to g sin theta for smooth inclined plane. Because in case of smooth inclined plane, this mu k will be 0. But whatever it may be, whether it is rough or smooth, is not going to make any difference in this problem, because from the first part of the problem we are going to find out acceleration. Okay, so you take in the first case of the problem, with the help of s is equal to e2 plus half at square, we can write L is equal to half at square, because here u will be 0. So on making t as the subject, you are getting under root 2l by a. So substitute the time, because it has given as a half second. On substituting the time, you are getting, and simplifying, you are getting acceleration as 4 meter per second square. Next, come back to the second case. What is that? How long will it take to move the next half meter? So in order to find out the time, how long in the sense we were asking to find out the time taken to move the next half meter, first make use of v is equal to u plus at, because it is started from rest, but after half second, definitely it will have some velocity. No, try to find out that velocity by substituting time as 1 by 2, acceleration as 4, so that we got v is equal to meter per second square. Again, friends, make use of ut plus half at square, right? And according to the problem, again half meter is given, so substitute that, and this will become initial velocity in the case 2. This 2 meter per second students, this is will become the initial velocity in case 2. So 2 into t plus half, a is 4 because it is uniform motion, uniform acceleration. Okay, and on simplifying this value, you're going to get t is equal to 0.21 seconds.